Welcome everyone. Welcome. Yaha, hello. I could see it was working. I was just talking a minute or something to nobody because I forgot to press the go live button. I'm RX, pretty bold of you to schedule this in a weekend. Yeah, you know how it's. I was like doing some research. When is the best day to schedule a live stream? And apparently the best day is a Saturday. Is a Saturday evening. Funny or not, for me it was as well. A bit of a surprise, but if you try and Google it, then that's the day that most people are available to be on a live stream. Hi Larkham, good to see you again too. Welcome, welcome to the workshop. Just gonna wait a couple minutes, see that people are a bit late. Maybe you're gonna join. Tundle, hello. Deepak, love seeing you as well. Nice to have you. So to people who are here, who've been here before, welcome back. You know how it goes. You've seen the previous live workshops. So welcome back, and for everyone who is new, um, welcome to you as well. Of course, my name is Hans Schreinemakers. Just a quick introduction. I've been doing this for 23 plus years. I think I looked into it recently. 23 plus years of working in automation, working with industry leading companies. I've been working with the likes of Pepsi, Nestle, Kellogg's, and yeah, I've been working mainly with Siemens and Rockwell. But for my training, I have been focusing mainly on TIA Portal because I had the feeling there was already quite some Rockwell out there, some Rockwell training. So I went to focus on TIA Portal, and so far it's well received. I would say people are liking the content. So you guys are here as well. So thank you for that. Let's see what else we got here in the chat. Kingsley, hi. Akraf, hi. Saber, amazing teacher, thank you. Before we get started, I'd just like to ask you one question. I always like to start with a question to get things going. And the question today is, what TIA Portal version are you using at the moment? So which version of TIA Portal are you using for your projects at the moment? What is your main TIA Portal version? Just write it down in the chat box. I mean, for me personally, I'm working with different clients, so I work all the way from TIA Portal 15.1, Service Pack 1 probably. Moses says 17, great. 15.1 all the way to to 18. Martin is using 19, that's cool. I've tried 19, but I've only done big projects up until 18. Using 18, 17, 15, 1. All right, Sebastian's using 19, download the version 20. That's on my schedule as well. I'm actually planning to do a video about it, about downloading and installing it. 18.9, that's good. So I see people are using 15.1 or later. That's what I thought. The 14, the 13, and the 14s are not being used so much anymore. Humphrey 18, Lewis using 19, Unified for new projects, 16, Advanced for legacy support. Great. Version 17. All good. Version 19. All right, so you guys are pretty much using later versions of TIA Portal. Someone still using Semantic Manager out there, or that's long forgotten? I have some projects once in a while with Semantic Manager, so I have to do some migrations once in a while. I have some customers who have older lines. I don't know which one is the most popular in the industry. I think it depends on the end customer. Some end customers, they just don't switch over to the new TIA Portal versions yet because of stability reasons. I know some customers who don't want to go with the latest versions because they wanted to give it some time to get the initial faults out of the system. So I don't have any clients working with 19 or 20 yet, but I do have clients working with 18. One support project in Semantic Manager, painful, yeah. I mean, if you come from TIA, then Semantic Manager is a little bit challenging. I mean, it's missing some features. Some old projects, Semantic Manager, yeah. Sebastian is using it as well. All right. Um, okay, so before we get started, I'd like to say that same as I said last time. So the principles that I'm going to show you in this live stream, they are independent of which version you use. So it's nice you're using all kind of different versions of TIA Portal, but the things I'm going to show you today are independent of the version. I always try to teach in a broad range, and the things I'm interested in are as well applicable to most TIA Portal versions because they handle about structure, creating organized software. And to be honest, there hasn't really changed so much in TIA Portal when it comes to that. The new TIA Portal versions always add a little bit more security, they add a little bit more features, a bit more fancy stuff like AI is coming, but actually the basics, um, the basics for making your software, they've been there since the beginning. So independent of the TIA Portal version, what I'm going to show you today, independent of which language you use. I do most of my programming in ladder logic, but I'm going to show you as well some examples with SCL today because it's just easier with arrays, some of that stuff. All right. And different than the last session where I had a 15-minute Q&A at the end, today I'm actually going to try and read your questions while I'm doing the workshop. So if you have a question, I would recommend writing question in capitals so it shows up clearly in the live chat, because if you write a lot, it's maybe difficult for me to see what is a question, what is not. So just write capital question and then write your question. And I will try and look at the chat once in a while I'm doing the workshop. All right? So if everyone's ready, then I'm going to start. To start with, I'd just like to explain to you what an array is. So arrays is like an array is a structured data type that can store multiple values of the same data type under a single variable name. So you will have one variable name with a list of values, all of the same data type. And it can be simple data types, which I'm going to show you, or it can be more complex data types like a structure. It can be a user-defined data type, etc. Some examples of arrays is, for example, where do people actually use arrays? This can be for data logging or data history. Data logging would be, for example, logging 100 temperature values. You would have an array of 100 and you would log 100 temperature values. History logging would be alarm history, for example. You can log alarms into an array and then you can go and check afterwards at the different positions. You can see which alarms you had. Another very interesting field for arrays is one that I use a lot myself, is shift registers. I work a lot with shift registers. And a shift register is basically on a line you have different positions. For example, a bottling line, you have different stations. And each position of that station has a position in the shift register, which actually translates to an array element, an array position. So that's an application for arrays as well, shift registers. And then you have, for example, FIFO and LIFO registers, which are first in, first out, last in, first out registers, which is, for example, like queuing of biscuit products on a biscuit belt. You could have a queue with a FIFO register. That is, those are some examples of why you would use arrays in PLC programming. Okay. Yeah, so that was a bit about where to use arrays. Now I will start with TIA Portal. I will show you where in TIA Portal you can use arrays. And let me just switch over to TIA Portal right here. This is TIA Portal version 18. I mean, it doesn't matter which TIA Portal you're using. And I will show you now where you can use arrays, where they can be, where you can add them, where you can declare them in TIA Portal, just as an introduction. So the first place you can declare them is in a global data block. So for example, if I add here a DB data block, and let's call this one, because I'm going to use this a bit later for examples, let's use a DB cooling. because I'm going to show you some examples with temperatures afterwards. And here under dB cooling, we can, for example, create a temperature log, and we can declare that as an array. I will first show you how to type it in, so you can just press enter. It auto completes an array of reals, because the temperature is a floating point most of the time, unless you want to keep it an integer and then scale it afterwards. But let's just keep this simple, and let's just say we have 100 values. There you go, from 0 to 99. So we have an array of 100 temperature values right here. Another array could be, for example, status bits, cooling status. Let's say this is Boolean, so cooling status. Let's say you have 5 coolers, so you would have an array, and I can show you what can be done here as well. You don't need to start with 0, you can start with 1. An array 1 to 5 of Booleans. So this could be, for example, 5 cooling stations with a status for each cooling. Exactly. Another place where you can create arrays are in functions or function blocks. I'll show you with a function right here. Add a new block. Checking the chat once in a while. So for example, FB cooling, just to keep it simple, right? FB cooling. And in a function block or a function, you can create arrays here in the block interface. So the input, for example, I'll just make it test at the moment. You can create an array, and you can see there's many types. This is, by the way, the same in the DB, so you can create it of hardware, hardware tags as well, timers, ISE timer, for example. You can create an output array, an in-out, that's possible as well, of character, for example. And you can do the same for static or temp. I mean, I'm not going to show all of them, but so constant you can't. That's the one thing. Constant needs to be a simple data type, so if you try to make an array here, it will just, you see the autofill, it's not autocomplete, it's not showing me array, it's not possible here. But for all the other ones, for the temporary memory area, the static memory area, the in-out, the output, the input, you can create arrays as well. So that's actually instance data. So global data, instance data, and the last place where you can create arrays are in the data types. So in the PLC tags, you cannot, for an input or an output, for example, you cannot create an array. But for a data type, if you would create a new data type, for example, UDT cooling, just as a UDT stands for user-defined data type. I think it comes from Semantic Manager. They used to call it UDT by default. And since I come from a Semantic Manager background, I kind of took over the naming from there. So here you can as well create, for example, a temperature log. And you can assign array of real. All right. So those 3 places you can declare arrays in TIA Portal. Global DBs, instance DBs, and PLC data types. Yeah, this is a little bit more advanced, but I'm just going to show you, like, an array can have multiple dimensions. This is just a one-dimensional array, but you can as well, for example, create a 2-dimensional array. Let's say, for example, you have 5 coolers, again, like the last example, with 100 temperature values. So you like to log for each cooler. Now you can see you have 2 dimensions, dimension 1 and dimension 2. So dimension 1 is the 0 to 99. Those are the temperature values, for example, and the 1 to 5 are the coolers you have. So now for each cooler, 1, 2, 3, 4, 5, you have 9, okay, you have 100 temperature values. It probably makes more sense, I see that now, to do the coolers first. It would make for a better example, because the first dimension, you clearly can see that I don't use this a lot. So now it's more logical. So the first cooler will have 99, 100 temperature values, the second cooler 100 values, etc. But you know, this is more advanced arrays, and to be honest, I've never used this type of array in my career. I never had any use for it. The one-dimensional array, that's the one that I use the most. Let's see where we are here. Yeah. Okay, so those are the simple data type arrays. Now I'll show you the more complex type of arrays that you can make. I'm not going to do it here. I'm going to do it in the DB. So these are just using single data types, the examples we've seen here. I'll just get rid of this one here. I'll now show you, for example, how you can make an array with a struct. So let's call this one, for example, temperature log2. And we take, for example, an array 1 to 9. Let's say we have 10 values to keep it more simple, of struct. So the data type structure, that is a data type where you can then add your own tags inside the structure. So I'll just add some simple data types here, and they will then automatically be used for the other elements in the structure as well. So let's say, for example, we have a timestamp. Sorry for that. Let's say we have a timestamp for our temperature log, which can be the long, date, and time format, which, by the way, you can use both in a 1200 and a 1500, step 7. There are some other time formats which are only available for 1500, a 7-1500, but if you use a timestamp in your projects and you're working both with 1200 and 1500, depending on the size of the project, I would recommend you use the DTL, because as you can see, I have a 1200, it works here. And yeah, I've been using that quite a lot. So you have the year, the month, the day, etc., the hour. So that's one of the structures that we want to define. Then we have the actual value, the actual temperature. And I've miswritten here temperature. This will be a real. Then we, for example, can have the valve opening status. Let's say we have a control valve in a cooling unit, and we have a 0 to 100%, a valve opening percentage. Let's keep that real as well, and I can just, to make it more clear, 0 to 100%. This could be minus 40 to 60 degrees, for example, which is like a standard range for a cooling temperature. And then, for example, finally, we can have a cooling status as well, which might be the status if your cooling is running, is not running, or is faulted. So it can use an integer, for example, where 0 is off, 1 is running, and 2 is faulted. And this here is the date and time. So now we've created an array of a structure, and you can see every element of the array contains this structure. And this is one way of creating an array of a structure. The other way, and that's the way that I normally do it, is by using a user-defined data type. So, for example, if we have a UDT called UDT temperature log, for example, to keep the naming the same. And then what we can do is simply copy these ones here, Control C, and I'll paste him here. So now the only thing I've done is I've taken those values from the structure and I've added them to the user-defined data type. So now instead of the struct, which, the struct is always created locally, and if you would use the struct somewhere else, you need to create that struct locally as well in the other function block. If you use a UDT, then you just need to add that UDT to whatever place in the software you're using it. So it's globally, and there's only one place where you have to change it, which is in the UDT. So I would recommend that you always, as much as possible, use with UDTs, because it's just, it saves you lots of time. Makes your software more modular, easier to troubleshoot. It only has upsides, the way I see it. So we just added this UDT temperature log, and you can see it's those same 4 values that I've added in the UDT that are visualized right here. Yeah, so those are basically some complex type of arrays. The big advantage I already told you. Using a UDT is global, a structure is local. Okay, that's it for the simple and complex data types. If anyone has a question about this, please write it in the chat. If not, I'm going to continue to the next part, which is where I'm going to show you some key instructions that you can do with arrays, some of the instructions that I use a lot in my own programming. And to go online, I have already prepared a bit. So I opened a simulation right here, which is just a 1200 PLC, which I dragged from here, and I started it. So that's quite simple in TIAPORL. That's already running. I've done that just to make sure that everything works. So the only thing I need to do now to go online with this simulation is just simply press go online. Yeah, and of course I made a lot of new things here, so we need to download. Even nothing is being called yet. I'll just make the download first. So just a little trick for download, Control-L. I use a lot of keyboard shortcuts. So Control-L for each time you download, instead of, clicking and finding the download button. Just Control-L download, Control-S for saving. Make sure you press Control-S at least a couple times, each hour, to make sure that your software is saved, because sometimes TIA comes with your unexpected error crash, and you might lose a lot of work if you forget to save your stuff. You're welcome, Martin. Yeah, these shortcuts, they are a lifesaver, all right, so we are online, everything is green. We have a function block here that we created to show these tests here. I'm just going to remove them. Not going to use them here. The only thing is this function block is not being called yet, so I'm just going to call it in the OB1 here, so we can actually do something in there. Yeah, that's fine. Just for example, I would not use those naming for a real project, but it's just a test. Okay, so now we are here in our function block, and the first instruction I would like to show you, which you can use for arrays, is it's maybe unexpected, but it's the move instruction. And what you can do with a move instruction, for example, is you can move one array into the other. So for example, let's say you have 2 equal arrays, temperature log 2 and 3, let's say. They both have the same structure. I have not changed it. And let's say we want to copy that. Let's remove this one here. Then we can add here the whole array. Either you just take one element of the array or the whole array, just like this. And you copy it to number 3. Download. Need to reinitialize the DB. There you go. And now let's try and put some values in this temperature log just to show you how it's working. Just gonna close these ones here, and then here's a little trick. So I have 2 blocks open at the moment, and I like to show them both. So there's there's a little button you can press on here. Let me find it, where you can split your screen into 2. I found it last time, but now it seems to be hiding somewhere. Yeah, it's not here. It's this button, split editor space vertically. F12 would have been there as well. Yeah. Yeah, that's interesting. That button was yesterday right here on my screen, but somehow I cannot find it at the moment. That's what happens when you're doing things live. All right, but now the good thing is we can do our examples here. We can do our instructions here, and on the right side, we can straight away. Okay, Marcin said, yep, thank you, Marcin. There you go. Found it. So this is the one. So this is the one to split your work area into 2, either vertically or horizontally. I think here it makes more sense to do it vertically. Yeah, now of course it's moved it around. There we go again. Okay, so we're moving array 2 to array 3. And now let's try, for example, to add a value here. By the way, to add a value, you can just double click here. So I'm online. So the glasses, as you know from Semantic Manager, if you're used to working with that, you just double click here, and then you add, for example, an actual temperature here. And you see it's being copied over right here. And we'll take the last one as well, just to show you that it copies the whole thing. Let's take the value status. Let's say it's open 45%. And you can see it's copied over. So this is copying one complete array to another. And one particular instance where this is very useful is if you want to initialize an array. Let's say you have an initialization sequence that you do when you start your PLC up. Then you can, for example, declare the same type of array right here. For example, init, you can declare this init array. And because it's declared as a static, so I'm just going to use the same size, which is 1 to 9 of UDT let's just see what it's going to tell me. 1 to 9 of UDT temperature log. There we go. And because you declare it as a static, everything is going to be 0 in here. So all the values in this array is going to be 0 unless you actually going to write over them in one of your networks, but you're not doing that. So this is a great way to initialize a complete array in just one simple instruction. So the only thing I need to do now is copy this one here. And before that, just have a look again at the log here, which we're using now, log 3. It has values in it, right? 31.545. So now I'll take this init array. I'll put it here on the end of the move. We load, and now you can see that, let's close this one, that our temperature log 3 is initialized. So the values that were in there before are set to 0. So this is a great way for initialization. So that is the move command. I'll just write here key instructions. Another Another very useful command is the fill block command. And that you can use to, that's only for arrays for simple data types, so not for structures or UDTs, but you can use that, for example, for this array right here, the temperature log, the real array, and you can use that to fill values of the array with one specific input value. So for example, temperature log 5. Yeah, that's, of course, I need to put the dB cooling in front. Temperature log 5. And let's say I want to add 31 degrees. Not 13, 31. And I want to do that 4 times. So now it's going to put 31 degrees into log 5, 6, 7, and 8. So we'll open this up so we can follow. And there you go here. So from 5 to 8, you can see we have 31. So this is great if you just want to like fill some elements of your array with a specific value. But once again, this only works with simple data types. So yeah, I sometimes use simple arrays as well. Most of the time I use UDTs though, but if you just do a simple array and you want to fill it, it's a great way to initialize as well a simple array like that. You can just add the value 0, and then the count is like the whole amount, the whole number of elements, which in this case would be 100. So you can use it for initialization as well. That is the fill block. Then I have an instruction here which I use a lot for the more complex arrays, which is the move block variant. And what the move block variant does is it allows you to copy a source structure with a number. So you can, for example, copy 5 elements from one array to 5 elements of the other array with structures or UDT arrays, and you can choose where you start or where you end. So for example, let's say we want to copy in this complex array, we want to copy the first 3, 0, 0, 1, and 2. And we want to copy that to the second array, let's say the last 3, 7, 8, 9, to keep it simple. So the source would be, again, need to put the dB in front. The source would be log2 array. The destination would be log3 array. And we said we're gonna copy 3 structures, 3 elements from this array, starting with 0, 0, 1, and 2, those 3, and we're gonna copy them to 7, 8, and 9. So the starting index is 7. And it needs a return value, so that's an integer. That's just like an error code, or that's a code that tells you if everything, if the instruction executed correctly or not. If it doesn't execute correctly, it will give you a fault code. So this can be just a local temp. And now we download this, Control L again. All right, and let's open these ones up. 7, 8, and 9, and 0, 1, and 2. So you can see already, yeah, I'll just use the first 2 here, that's easier. 31.5, you can see here. I can, for example, change this to 27.3, 15%, 1. we can see it gets here. For example, I use the last one, the third one, 25. And now if you see, if we take one more, that doesn't do anything. We just copy these first three to these last three. So that's what you can do with a move block variant, and what I use it for a lot is for shift registers. But I think I'm going to do a separate YouTube about that. Either a workshop, or I'm going to make a YouTube video about it. But for shift registers, you can like copy. You can move all the arrays one position, all the elements one position, which is what a shift register does. So for each trigger, you would shift all your data one position forward. So for that, the move block variant is a very good instruction. There's one little caveat here, one little thing you need to remember, and that is the source index and the destination index. They are zero based. And what that means is, I mean, we start here our arrays with number 0. But as I showed you in the beginning, you can as well start, for example, at number 1. And zero base means it would be the first element of your array. So if this would be array 1 to 9, then source index, this 0 would mean array 1. So it's a little bit confusing. If this would be 5, now 0 would mean array element number 5, 1 would mean array element number 6. You see, it's so for that reason, I would recommend, if you work with structures or UDTs in your arrays, always start with 0 as your first element, because most likely you will be using this move block variant command to do some manipulation of your arrays, and you just don't want the extra headache with thinking, what does this source index, how does it relate to the starting point of my array? So just start with 0, and then this number correlates directly to the element number in your array. So that's quite easy. Let's put this back at 0. All right, all good so far. No questions I can see, so hopefully that means it's clear. I'm just gonna have a sip of my berry juice, because my voice somehow seems to disappear with these longer talks. And finally, yeah, I have 2 more commands for you, 2 more instructions, and I use these ones a lot as well. I'm just gonna disable these to make sure they don't interfere with anything afterwards. And that is lower bound and higher bound commandos. And I'll just put them first here, lower bound, higher bound. And what they do is they will give you upper bound, not higher bound, upper bound. They will give you the first element of your array and the last element of your array. So that's something that's very useful if you work with dynamic array sizes. If you work, for example, with different shift register, different sizes, for example, different temperature loggings, like say you have one logging of 100 values, then for another part or unit of your machine, you're logging 200 values, and you want to build one function that manipulates those values, that can handle different sizes of the same array type, so the same structure, the same UDT. Then the way you do that is you add the array as an input-output on your block. So I'll just show it here, an array temperature log. And instead of declaring, like I said, it's a dynamic array, so you don't really know the size. You don't know if it's 0 to 9, 0 to 100. What you do then is you put an asterisk like this. And this makes the array dynamic. So now here on the front where your function is being called, just to show you here, now you can add an array of any size here. The only thing, it needs to be the correct data type. So it needs to be UDT temperature log. But apart from that, it can be an array 1 to 10, 20 to 50. And like that, you can just build one containerized block of logic, one logic that can handle different array sizes with the same, how you say, with the same kind of calculations on that array. So maybe you do some averages of that array. I will show you in a second some examples how you can use it. So to get back here, we have the lower bound, the upper bound. They only work with these type of arrays. So with the asterisks, with the dynamic type of arrays, I can show you if you put a fixed array size on it, it will just give you an error saying that the actual parameter does not match the data type array, asterisk, or dynamic. So you need to put this type of array on there. And then the dimension, we just, like I told in the beginning, we're using a one-dimensional array. One-dimensional being this, as I told you before, you can do two-dimensional like this, but we're just using one dimension. So that's what the one stands for. And then the output would be the result. So what is the first element, the low limit of your array? So let's just call this, for example, I. It's very hard to quit, Saber. All right, but thanks for joining. And you can always, you can always watch it afterwards. It will be here on my channel. First element. So let's make this into a static. Okay, we can make it double integer. Apparently that's the preferred output here. And here the same, the upper bound. So the last element, dimension 1 once again, last element. Static. All right. And now the only thing we need to do is put here in our OB where we call it, we just put the array in front. So for example, I'll put this one here. Now it will save and compile and download. Data blocks will be initialized, that's fine. And now you can see, I'll put the dB here so we can follow along. That for temperature log 2, our first element is 0, which is this one right here. And our last element is the 9. And then one thing that I typically do as well, you can calculate the size of your array, which is quite good if you, for example, want to fill it with a value, then you start with 0 and you fill it for the complete size. And for that, you can use the calculate block, which is a very useful block in TIA. And the size is simply the last element minus the first element plus 1. So that's input 1 minus the last element plus 1. And then you will have the size. There you go. And we download again. And now you can see size is 10. We have from 0 to 9, 10 elements in our array. So that's typically, yeah, that's like actually very good logic to put in one function block, like as like a basic instruction you do on complex arrays, like calculate your first element, your last element, and your size, and then you can put those as an output, and then you can use that for any size of array of that specific data type. again, that's how you work more modular, create small blocks that do these type of calculations, so you don't need to write them all the time. You just write them one time, and then you reuse it for in every location of your program where you need to use it. Okay, that was the lower bound and the upper bound. So this is only possible for complex arrays. You cannot do this. This is possible for simple data types, but it's only possible for dynamic arrays. Yeah, that was what I was gonna say. And just for fun, let's just do 5 to 15 or to 21 for temperature log 3, so you can see the difference when I put this one. So it's a different size of array. I'll put this as the input for the block. I will load. Invalid assignment. Yeah, okay. Because we changed the size and the init array is not that size anymore. We remove this instruction because we're not going to use it anymore. And now you can see that we have our first element 5, our last element 21, and the size is 17. So from 5 to 21 are 17 elements. Okay, I see Marcin has a question. How do you practically use size information? That is what's coming up at in my next examples, Marcin. So I will show you how to use this size in a couple minutes. So if you still have some questions, then please ask him. But yeah, I'm gonna do that after the next thing. So the first thing I'm gonna do, yeah, you're right, it's gonna be a for loop, Marcin. I'm first gonna show how to access array elements dynamically, which means using an index variable, and after that I'm going to show you some examples of loops to get process information, data information from your arrays. So to access an array dynamically, and that means dynamically means we create a tag, and using that tag we are going to, the tag can be a value from the HMI, or it can be a value through your software, through your logic. And with that value, you define which element of the array you want to look at. And to do that, we first need to make an index variable. So I typically just call this index a double integer. As far as I know, it just has to be a whole number. It can be an unsigned integer. It can be an unsigned double integer. It can be an integer, a double integer. And what we do then, I'll just name this index variable. And this one was, lower upper bound. And what I'll do now is I'll move a value into the index. For example, index, we move the value 1. And then I'm going to get the value from the array using the index. So for example, db cooling, and then instead of the fixed number, the element, I put in the index variable. And let's, for example, get the actual value, and we transfer it just to a temporary variable, just as a test. Actual value. local temp. All right. And at the moment it says, so it says it uses index 1. So index 1, that's element 1. At the moment that's 0, but if we put something in there, 15 for example, you can see right now that we're indexing. So this is indirect. We're not directly looking at the 1, but we say we want to use 1 here as our element, and we have 15. If we, for example, put temperature 31.5 in element 3, and we say we want to transfer, we want to have a look what's in the, for the actual value in position 3 of our array, then you see now it's looking right here. So this is called indirect addressing, indirect or dynamic access. It's called as well dynamic access to an array element. I mean, this can be useful. For example, let's say you have an HMI and you want to scroll through your temperatures in your log, then you can make an integer or a double integer on your HMI. And then, for example, with the plus button, go up in the integer, with the minus go down, and then you can go through the different array positions and dynamically get a different temperature, a different logging temperature. That's one example to use it. Exactly, yeah. So that's an index variable, and that's quite important for our next step. And this will be the last step that I'm going to show you, and that is how you can get specific data, information from an array by looping or iterating through the array, and so going from the first element to the last element, going through all the elements and finding some values or calculating some averages doing that. And to do that, I told you in the beginning I was going to use some SCL. Personally, I don't use it a lot, but I think in this case it's very useful because it keeps the code very short. I've done this in ladder logic as well, but just for fun, I thought let's do it in SCL to show you how you can do some more compact programming. And this is a great thing in TIA Portal as well. You see I have a ladder logic block, but I can very easily just add an SCL network right here, insert SCL network. And now I just got an SCL network in between my ladder logic. So if you have some instructions or some logic that is easier to do in a text-based environment, but your standard is ladder logic, you can just do it like that. So what we're going to do right now, we're going to use this temperature log 2. We're going to scroll or loop through all the 10 elements. And let's, for example, we're going to put in some values here, some different values. And then we're going to find the highest temperature value, the lowest, and we're going to create an average of all the temperature values. So to do that, we're going to need to create a for loop, and that is done with an index tag, which we already have. And we start by typing for. That is the starting number, which will be, and this is quite interesting because we just did the lower bound and upper bound. We have the first element and the last element. So we start at the first element and we're going all the way to the last element. You can also write the step. I think if you don't write it, it will be default 1, but I'll just write by 1, which means we're going to go one step at a time. So we start at element 0, then 1, then 2. You could do by 2, then you skip, you do 2 steps at a time. And what we want to do, let's just first make this for loop like this. So this will be a loop for index 0 to, or first element, which is in our case 0, to last element 9, by 1. We are going to, what did we say? We're going to find the lowest value first. Yeah. So, yeah, the lowest value. So we need to declare that. So let's make one temperature low, lowest, temperature highest, and I'll make the average one as well because we're gonna have that. Gonna do that in a sec. And temperature average. There we go. And the way we do that is, let me just see if I have it here. Yeah. So if our value in that array element, I'll first write it and then I'll explain it. That's going to be easier. There we go. Just add some networks here so it can go a little bit up. So what we're saying is if our element, so 0, 1, 2, 3, 4, 9, if it is lower than the existing lowest temperature, then our new lowest will be that value. The only thing we need to do is initialize that lowest temperature. We just put it very high so we know that every value that's going to come, the first value that's going to, I mean, that all values are going to be lower than that. So for example, 10,000. And then afterwards, just to check if it's correct, I sometimes do that. That's easy for troubleshooting. You just move the value into itself again, because then afterwards it's easy to check the value when you're online. And now what we still need to do is let's give these some different values. I'm just gonna put 10 quick values here, and I'll put the lowest one. I'll let you know when I'm putting a lowest one, so it's easy to remember. 21.5, 15. So let's take this as our lowest. So everything that we put in is higher. 35.2, 31.5, 29.3. 70, 16.2. Two more. 19.7. 22.8. So now we put 10 values in here in our array. And let's download this and see what we get. We have 0 at the moment, so either we still have a mistake. As you can see, it's hanging at the moment, so I need to wait. Oh, yeah, that happens. So we were thrown offline. Yeah, I know what happened. I know what happened. That's good, because that's good for troubleshooting. Just need to wait a little bit until TIA portal gives me permission again. I think I did an overflow of the array because I forgot. See, the low and the high. The low and the high that I calculated was of the other array, was of the temperature log 3. Yeah, at the moment it's really moving slowly. I think I need to stop this one here first. See, the problem is the first and the last element that I'm calculating that from temperature log 3. And we changed temperature log 3 to a different array size, which means right now we're trying to loop from element 5 to element 21, but we're trying to do that on the temperature log 2. And the 5 works, but as soon as it goes over 9, it's not working. And our PLC goes and stop because we don't have the right OB, we don't have a program error OB downloaded. So that's another tip. So if you want to make sure that you don't get these things during production, make sure you add like an error handling OB. I think it's 121, but I'm not 100% sure. Something like that. It's this one right here. Programming error, it normally says. Polar plug agnostic time error, hardware interrupt. Yeah, I would have to look it up. Normally there is an error OB for that as well. But okay, at the moment we are just going to make it right by adding the right temperature log here, making the download. And putting the PLC back in run, because as you can see right here, we're still standing and stop. Another way to check the status of your PLC. Yeah, I'm gonna let that go for now. Let's just go back and run. There we go. And as you see right now, we're having the correct values here, 0 to 9. Nick, why does it not catch this error in compile step before downloading? That's because we're doing dynamic access to arrays. So it only realizes that you're out of your array once you go to run. Because here we're using tags for first and last. And it doesn't catch that. It doesn't know until you're in run what is your first element and your last element, because it's all dynamic. So that's why the error first. Okay, that could be Sebastian. That's the reason why I didn't find it. Normally, I mean, I normally work with 1500s, and there I always find I always use the programming error OB, or can't remember what it's called exactly, but I think it's right. It's 121. No, so that's the reason, Nick. It's dynamic. If it would be not dynamic, you cannot type it in, right? You could not type in 25 in temperature log 2. It just wouldn't accept it. Okay, but back to our example, which, I mean, we're still in run, but it is, yeah, of course it put all our values back to 0, yeah, because we downloaded everything again. Yeah, so we quickly put values back in here. So 15 was our lowest one. I'll just take whole numbers now just to make it quicker. 15, 18, 21, 24, 36, Let's give a high one here, 42, 22, 19, and 29. There we go. Now it worked. So you see, we have, so we iterated, we go through all the values, and we found the lowest temperature, 15. If we put this one up, for example, to 31, then it finds 18, which is the next, lowest one right here. I just saw it right here. Now we can do the same for the highest value. So I'll just go offline here, not offline, but just stop the monitoring. And I'll do the same here. I just give an unrealistically low value for the high one first. Should actually be floating point. And then I can use the same for loop. I just need to use a different if instruction. And now we do, instead, if it's smaller, we say if it's bigger than the highest, and everything will be bigger than minus 10,000. That's why this will work. Then the highest value, the new highest value will be that actual value from the iteration. And here again to check the output. Maybe it's because I'm not used so much to working with SCL that I program these last lines here. Maybe you can see it. No, you cannot see it in the loop itself. No, that's true. But maybe there's a better way of doing this. Okay, everything is up to date. And now we go online right here. And you can see that the highest value in our array of 10 temperature loggings is 42, which is a value we can find right here. So if we change this, for example, to something low, let's see what it finds then, 36, which, yeah, it's this one right here. So that's the highest, that's finding the highest and the lowest value of something in an array. The last thing I'll show you is how to find the average. And for that we don't need to initialize that. So what we're going to do is we're going to create a total. We do need to initialize one value, that is total temperature. We're going to count up all the temperature values, and then we're going to divide it with the size of our array. And that, Marcin, what you asked before, that's why we calculated the array size. So now we can use that value for an average calculation. Total temperature, so we start with 0, for example, and we still need to define the stack. A real. And what we're going to do, we're going to iterate through all the elements, and we're going to say that the total temperature, which starts at 0, we have nothing in it yet, is the previous result from the iteration plus the new result, temperature log 2, and we use our index variable right here like this. I need to put actual value still in there. Yeah, this became quite long. And that gives us a total temperature, and the last thing we need to do then is, after the iteration, we need to divide that total temperature with the size of the array to get the average temperature. So the temperature average is the total temperature, the sum of all the temperatures in the array, divided by, I think it was a double integer, the size. Exactly. Yeah, that's by the way, TOportal does that. You get a yellow kind of line underneath this calculation because you're dividing a real by a double integer. So it means that it says it might lose accuracy if you just hover over it. It says a loss of value accuracy is possible. That is fine for this example. Achraf, yeah, I just saw you ask the question, are these temperatures values in real life app coming from different sensors, or is it just a history value for the same input? I mean, I would say it makes more sense to have a history value for the same input. You know, if you do a logging, if you have a cooling tunnel, for example, and you want to log how consistent your cooling is working, then you might want to keep a log, let's say every minute. I mean, it's typically a slow process, a cooling tunnel, you know, cooling biscuits or cooling something down. I work a lot with molding lines, so it's cooling down a product. I think I've done this at a customer. I mean, I would take a log every minute, but you know, maybe it's enough to make it every hour. It's just extra data that your customer can use for detecting faults in the system. For example, if it sees your cooling is going up and down, it might have to look at the PID, or there might be a fault in your cooling circuit somehow, a valve that's stuck. All these things can make sense. All right. So that was the last part, the average temperature. So we got a total temperature, which is 247, divided by the total size, which is 10. So you can hover over the variables to see 247 is the total sum of these 10 temperatures, divided by 10, which is the size of our arrays, 10 elements, which gives us an average temperature of 24.7. Nick says, thank you so much, Hans. Super useful. Yeah, thanks. Very cool, Nick. I guess you're checking out. See you next time. Marcin, how do you define timestamps to save the log? I mean, to get the timestamp, you first read out the time from the system. There's a specific instruction for that. TOportal, I think it's read system time or something like that. I can't remember it by heart. I would have to read. It's some kind of a read instruction. I would have to look it up. Read clock or something like that. Then you read the actual system time of the PLC, and that's in DTL format, and then you transfer that to your temperature log. Martin, on the topic of data logging, have you worked with external DAC systems such as EBAR? Do you usually do it directly in the PLC? Martin, no, I've not worked with DAC systems. I have used with SQL databases. I don't know if that's something in the line of, I mean, the DAC system doesn't really tell me, I mean, it's not familiar to me, but I have worked with SQL databases where we send data there, but it was not meant for logging. I mean, I would say if the logging is not too big, if it's not big data, so to speak, you can do it in the PLC. It's easy. If it gets too big, then I would look, for other options like sending it away from the PLC to a third party system. Moises, you write something about a pre-built function that can be applied to arrays. Can you tell your question in a different way? I'm not really sure what you mean by that. Marcin, what do you mean how to split it? I mean, yeah, you can split the date. I mean, the date and time format is already split. If you look at the timestamp right here, you already have year, month, day, week, day, hour, minute, second, nanosecond. So you don't need to like manually, I know in older logic or semantic manager, you needed to take each byte separately and say which byte is the year, which byte the month, but here it's already structured. Yeah, Marston, like I said, every minute depends on what you're logging, you know. For a cooling temperature, maybe it's enough every minute. If you want to log something very fast, if you want to log something else like frequencies or servo positions, maybe you need to log it more often. But I typically don't use array for that kind of stuff. Okay, Lou says the CPU can function as a data logger as well. Yeah, that's probably it, Rafael. The RD system time. Yeah, you're probably right. I mean, I've used it in many projects, but you know, I don't remember every single instruction that I've used. I just typically have to look it up. You mean, okay, Moz, you mean like an average function that takes arrays as an argument? No, as far as I know, there's no pre-built functions that kind of do calculations on arrays. There might be some libraries from Siemens. I haven't checked that out. I always make my own libraries because my customers are quite specific with what needs to happen with the arrays. But could be a good thing to investigate to see if there's some Siemens library somewhere that actually already do some array calculations. Yeah, one last thing with these for loops here is that, yeah, just as with some of the other instructions here, it can be used to initialize an array. So you could, for example, say for first element to last element, write 0 to the temperature, 0 to the valve status, 0 to the cooling status. So you can initialize your whole array in a for loop. That's an easy way as well to do that. That's actually all I have for today. So this was an introduction to arrays in TIA Portal. I mean, you can go way more advanced, but these kind of things that I've shown you, these principles today and these instructions today, I use a lot in my own programming. You can do a lot of things with them. Maybe I'll do a YouTube video in the future of a practical example of arrays. Someone gave a very good example of a bottling line, has written me like if I can do something like that. So that might be something on the horizon. So yeah. So before you go, I have one question. I did the same in my last workshop. What was your biggest takeaway from this workshop? So what was for you something very valuable that you didn't know before, something that was new for you, exciting for you, and that you think you're going to probably use in your own PLC programming? Just write it down in the chat box. Is there anything that you said like, okay, I didn't know that. That was good to know? Any takeaways from this session? Anything you learned? Anything you learned? Anything you unlearned? Anything you didn't know? Marson says, was nice to see some SCL, how you put all if loops in the for loop. Yeah. Sebastian said, didn't know about the 2 dimensions of arrays. No, I haven't used it in 20 years, Sebastian. So dynamic array sizes. Yeah, Martin, that's something I learned in the last couple of years, but it's very good if you work with different sizes of the same data type of array. And you just want to build a block that handles that type of arrays, and you don't need to make a separate block for each array size. You can just build a dynamic array as an in-out, and yeah, that was a very good thing. The functions, good. I learned how to work. Yeah, that's good. Moses, new to TIA Portal. That's good. Arrays are very useful in TIA Portal. Ashraf says it was very useful to know how it works in the first place. Need practical examples. Yeah, exactly. That's what I said. I think I'm gonna plan maybe not a workshop, but like my other tutorials, like an actual YouTube video with maybe some more pictures and to show an actual practical example of an array. Thanks, Lou. Good presentation, he says. Thank you. No, Martin. I don't do electrical engineering and schematics. My expertise is purely in software development. Yeah. All right, George. Good to know. More advanced stuff for array. No, a 1200 Marston does have error handling, but it might not have exactly the same error handling as a 1500. Like I said, I work mostly with 1500, so I know the OBs you can use there, but I'm not 100% sure. And it probably depends as well which type of 1200 you're having now. There's a new 1200 generation 2 that probably has much more options as well. But the 1500, yeah, like Sebastian says, they're more advanced. They can do more advanced motion. They are faster. I do mostly big production lines, and they use always 1500s or technology CPUs. Yes, this session will be on YouTube, so you just have to go on my channel and look at the live tab. You will find the other two live workshops that I've done as well. All right, there's just a couple of things before you go. Don't go straight away. There is another array blog post which I've done a couple years ago. So if you go look in the description below this video, you'll see there's a link to a blog post about 4 array hacks in TIAPortal, and there is a downloadable project. So if you want to go and check out a real TIAPortal project with arrays, for example, this dynamic array is in there with the lower and the upper bound. That's a TIAPortal project that you can download from that blog post. So go and check that out. And as I've told you before, if you want to get started with TIAPortal, if you want to get started with creating organized PLC applications in TIAPortal, then don't forget to download my free guide, which is in the description as well, not the destruction. The description below this video. So there is a free guide with 5 simple steps to drastically change the structure of your PLC applications in TIAPortal. After that guide is downloaded, you will get additional emails with lots of value, with more videos, more blog posts, more information about TIAPortal, really. So if TIAPortal is what you're looking for, I got lots of value there in the emails. Okay, so that's it for tonight. Enjoy the rest of your weekend, and I hope to see you soon on another workshop. All right, good night.